So what do we got here? We have a force. We got K is equal to force over X, right? Well, let me go. Let's back up. Where'd that come from?
KX.
Force equals Kx, right? All right. So K is equal to F over X. So it's the same spring, so it's the same K for each case, right? So that means that's in general. So since we know that K is the same, we know F1 over X1 is equal to F2 over X2, right? So it's just going to be a straight ratio here. If we're looking for the force needed to compress the spring by this much, we'll call that F2. We'll say F2 is equal to X2 over X1 times force 1. Just what we've been doing all year with ratios, right? So that means that F2 is equal to, what's X2? We'll just multiply everything by 1,000. 508 over 191, right? It's the same thing, right? Since it's just a ratio, times what's the initial force? 89 newtons, okay? 89 newtons. If you want to put the decimals in there if it makes you feel better, that's okay. So, does it make sense that this is going to be bigger than 89 newtons, right? Does it make sense? Sure, because before it was 0.191 newtons, now it's, 0.0191. All right, now it's 0.58. So it's a greater distance, so we know it's going to be a linearly proportional, right, to a greater amount of force. So 5 over 8 over 191, again, it's around 2.5, 2.6, 2.58, 2.56, 2.36 times 80.
No,
it's times 236.
You're right the first time you spoke.
No, I already multiplied by 8.
Okay, what was this?
2.65.
2.65. What are the units?
None.
None, right, because it's distance over distance, right? That's why I didn't even write them in to begin with. I was getting very lazy. All right, times 89 newtons. So that is, Catherine? 2.36 what? Is it round to 7?
Yeah.
All right, 2.37 newtons? Yes. Still newtons.
Yeah, it's 89 times 2 is still going to be.
Yeah, come on, what is it?
237. There we go.
We'll go with 3 sig fig. Somebody go back and tell me why I'm wrong later. All right, 237 newtons. That is